Okay, so to build on our understanding so far, so we know what an angle is, we know how we're going to measure it, and right now the way our definition is, those rays can begin starting in any direction, right? And so it gets a little complicated, so to simplify things, to make sure everybody's kind of looking at the same picture, right, what we have is what we call standard position, or standard notation, or I should say position, I'm sorry, all right, angle. Okay, and what this basically means is that the initial side, right, coincides or is along the x-axis. Okay, and this is going to help everybody stay orientated, whatnot. So let's just go back. Let's say we had that 30-degree angle that I discussed in the last one. We're going to kind of take a look at our x and y axes. We're going to put our initial side along the x-axis, and then since it's positive, I'm going to rotate roughly about 112 or 30 degrees rotation from there. So the initial side always starts along or coincides with the x-axis. The terminal side ends wherever the rotation wants me to end. So let's go ahead and say we had a 90-degree rotation. Right, so what we have there, right, for 90 degrees is my initial side will always start along the x-axis, and we're going to rotate. 90 degrees is basically a 1/4 full rotation, so it takes us basically along the y-axis. So hopefully we can kind of see my initial and terminal side there. Right, so there's our 90-degree angle, a 90-degree rotation. All right. If we wanted to go, let's say something like 150 degrees, right, that's going to basically take us along this. Okay. So again, our initial side begins along the x-axis, right? So there's my initial side. Here's the y-axis. We're going to rotate past 90 degrees, right? We're not going to go quite a half rotation, right? Because if we go a half rotation, we've gone 180 degrees. So 150. Right, probably is right about there. All right, and so there would be my best representation right now without a calculator, excuse me, without a protractor, what a 150-degree angle would look like. All right, so again, its initial side coincides with the x-axis. Its terminal side, right, basically would take us past the y-axis and almost close to the negative side of the x-axis. So there's a 150-degree rotation, and on and on and on. Right, if we're talking 180 degrees, that means we're basically going through a half rotation. So here's my x and my y-axis. There's my initial side. We come around, right, and roughly there would be 180 degrees, and that basically means I started looking along this direction. After a half rotation, I'm now looking along the other direction, right? And again, on and on and on. So I'm hoping you guys can kind of get the idea from that. Okay. Of course, if we were right now, I've rotated positively. If we were to rotate negatively, right? Let's say I wanted to go a negative 210 degrees, right? That means I would start right in the positive x-axis. It's negative, so my rotation's this way. I'm larger than 180, right? So I'm going to go past half a rotation, and doing a real quick subtraction, there's about 30 degrees past that. Okay, so we're basically heading right there. So there would be the measurement. Let me write that a little nicer. There would be a measurement of a 210, a negative 210, right, rotation in standard position. We're starting along the x-axis and rotating negative 210 degrees. Okay, so hopefully that gets you going in terms of that. Again, we usually want to consider ourselves in standard position. That way everybody kind of has the same picture in mind, even though we could have, done a 30 degrees over here or 30 degrees over there. So standard position is relatively important. As I drew those pictures, right, we have some other terminology that comes into mind. One of these is the idea of acute angle. These basically angles that your theta is less than 90 degrees. So 30 degrees would be our example of an acute angle. The rotation is less than a 1/4 rotation or 90 degrees. There's also angles that are called right. Right? These type of angles that are right, the angle is exactly equal to 90 degrees. So this would be a right triangle. all right, because the rotation was exactly equal to 90 degrees. There's some angles that are called obtuse, all right. This means that their angle falls somewhere between, let me write it this way. The angle we're looking at, the rotation, is greater than 90 but less than 180. So here's an example of an obtuse angle. As a matter of fact, you know, technically speaking, this would be an obtuse angle, right? Because you know, just throw some negatives in front of there. This rotation, right? Excuse me. This would I'm getting ahead of myself. I'm sorry. I'm thinking about another concept. All right. So I apologize. So obtuse angle, we're between 90 and 180, and then last but not least, what we have is what's called a straight angle. And this is when my angle is exactly equal to 180 degrees. And so here would be our example of a straight angle. So again, we're in standard position. Of course, you do not have to be in standard position to be acute, obtuse, right, or straight, but it's kind of nice to get our bearings when we talk about those kind of situations. All right, and then last but not least, this is what I was building up to. What we have are these things called coterminal angles. All right. So what a coterminal angle basically is, right? These are angles where we basically have the same initial side and the same terminal side. There are an infinite number of them because we just basically talk about full rotations. So quite challenging, especially when you start graphing sines and cosines. But essentially, my first example of coterminal angles, and this is, I got ahead of myself here, these two angles here, 150 degrees, is what we would say coterminal to negative 210 degrees. And the reason why I'm saying that they're coterminal is because it satisfies my definition that the initial side and the terminal side are the same. And so when you look at this, right, again, the initial side is along the x-axis. When I rotate 150 degrees, we're left with about 30 degrees left for a half rotation. But when I rotate a negative 210 degrees, we go past that 180 degrees, negative 180, and about 30 degrees right there. And so this means that this terminal side, even though my picture might be a little off, this terminal side coincides with that terminal side. So these two angles are what we call coterminal. They're not equal, all right, but they're coterminal. They share the same initial, share the same terminal side, but we're not saying that they're equal. Notice there was a different rotation to create them. What's making them coterminal is the fact that they had the same initial and the same terminal side. And to go to the fact that there's an infinite number of them, right, let's just go to our 30-degree angle. To find something coterminal to it, all I have to do is keep rotating 360 degrees. So 30 plus 360, one of my first positive rotations, or coterminal angles, would be 390. Of course, if you wanted another one, you would just rotate another time. So 30 degrees plus 360 and plus 360, right? And whatever the heck that turns out to be. Let's see, 390 and 360, carry the 1, 750 degrees. So you can get the idea that there's an infinite number of positive, right, coterminal angles. And for that matter, there's an infinite number of negative ones, right? Because if I basically took 30 degrees and subtracted 360, right, that would mean that the rotation is now going the other way, right? We would end up with negative 330 degrees, which basically the rotation would be this right here, like so. And there would be negative 330 degrees. So the concept of coterminality is important. It's kind of crazy because there's an infinite number of them. You basically just keep rotating a full rotation to get a positively or negatively to get an infinite number of positive coterminal angles and an infinite number of negative coterminal angles. All right, so we're 9 minutes into this. I'll stop. We actually have more things to talk about, but I'll cut away to a new video and we'll start fresh and new.